Okay, so we continue from where I had stopped. I just wanted to focus the camera here so that you get to see. For us to find an estimate of the gradient, so gradient is simply changing y over changing x. So changing y over changing x, we are looking at this region over here. Changing y over changing x. So how did y change from 0.3 all the way to 2? You find that this is where we compute y2. I've already shown you how to come up with this. Is 2 minus 0.3. You can also see it from the graph. The change from here, this point is 0.3. The lowest point on the parabola was 0.3. All the way to 2. What is the distance from 0.3 to 2? You find that it is 1.7. Even here it can show you 2 minus 0.3 is 1.7. Okay. Then also in the x, the change from negative 0. This looks like negative 0.5. Yes. From negative 0.5. Negative 0.5. Okay. All the way to 2.2. What are you going to get? Okay, so you say 2.2 minus negative 0.5. Okay, they are adding because we are looking at the change, or in other words, the distance, change in distance in terms of y. Divide by change of distance in terms of x. Okay? That's what you are looking at. That's the reason why they end up adding. You're looking at the range. So therefore the gradient is going to be 2 minus 0.3 is going to give you 1.7. Okay? 1.7. And 2.2 minus negative 0.5. Okay? So remember the units were centimeter, but at this point they are going to cancel. You can show them and you show how they cancel. Gradient doesn't have units. So this is going to give you 2.5. 2.5. Okay? 2.5. If you divide 2.5, 1.7 divide by 2.5, I think this is going to give you roundly 12, it should be 0.3. Yeah, 0.3. 1.7 divide by 2.5. Or it's going to give you 0.68. Okay? 1.7 divide by 2.5. That's going to give you 0.68. So, if we are putting it in one decimal place, we're just going to put everything in one decimal place. Since everything they are putting them in one decimal place, we're going to say it's going to be 0.7. If, since 8 is above 4, so we just add a 1 unto 7, so it becomes 0.7. Wow, so this is the gradient. So the gradient is 0.7. We've looked at that. So we're done with that part. Now show your method clearly. Use the graph to solve the equation x squared minus 2x plus 1 is equal to 1.5. So I'm going to erase this part. Yes, this is a video you'll be able to pause so that I have space for the last question. Okay. Back to this. So basically, we want to solve this. X squared minus 2x plus 1 equals to 1.5 using the parabola. Okay? They're saying use the graph to solve this. We're going to use the graph. Now, if we look at the equation that connects all the points on the graph, you find that it is the very equation x squared minus 2x plus 1, which is this one, right? So y is equal to, according to the question here, y is equal to x squared minus 2x plus 1. So meaning, where there's x squared minus 2x plus 1, to make my life easy, I'm just going to say this is y, because y is equal to this, which is equal to 1.5. See that? Okay, y is equal to 1.5. Where there is this expression, it becomes an expression if I cover the equal sign. Okay, without equals, it is an expression. When there is an equals, it becomes equation. So like this is a quadratic equation. If I remove the equal sign, it becomes quadratic expression. Okay. All right. So y is equal to 1.5. This equation is equal to 1.5. So when I've done that, I just go on my graph now. I draw the line y equals to 1.5. Okay. I do not have a ruler with me right now, but you having a ruler, you're gonna make sure that you draw a straight line at y equals to 1.5. So y is this, 1.5 is here on the middle. So I'm gonna draw a straight line. Okay, you draw a straight line using a ruler, and on your Cartesian graph, it has to be straight. So I've just drawn that. So where that line meets the parabola, where it cuts the parabola, I'm going to get the values of x, and that's my answer. So like here, let me just twist the camera so that you see very well. My line over here cuts the parabola here. I'm going to draw lines coming to x. So, and this side, I'm going to do the same. Okay. So I find that this line 1.5, it cuts the parabola at negative 0. This is 0.3, negative 0.3, and 2.2. So x is equal to negative 0.3, comma 2.2. It's done. I've solved using the graph. Yeah. Now, you might be wondering, this is where people get confused. Let me just make this clear also. You better pay attention to this. Because what usually happens, you find that a teacher has taught you like this, you go in the exam, you find there's a different value there, then you get confused. You say, no, but the one that the teacher taught us, it was exactly as the equation which was given. But in the exam, the one that they've given us to solve is a little bit different from the one, or is different from the one that we were given. What if it was like this? This one I'm done solving, I'm going to erase it so that I show you different ways in the exam they can bring that. What if they had said, now, what if this question was saying, show your methods clearly, use the graph to solve the equation if here there was 3 instead of 1. So, which becomes slightly different from the equation which connects all the points given from the question. Okay, which becomes a little bit different. So how are you going to tackle that? Well, it's still easy. Okay, all you have to do now is you have to make this one. Okay, I think white is just okay for you guys. I think white is just okay. So x squared minus 2x plus 3 equals to 1.5. Now, when it's like that, all you have to do now is you have to make this one to be equal to the equation of y here given. Okay, how am I going to do that? Since here there is 3, I want it to be 1 there so that it is exactly the same as this one. So that means I have to subtract 2 here. What I do this side, I have to do it on the other side. I'll subtract 2 even this side so that it gives me 1 here. You see that? So I'm going to do x squared minus 2x plus 3 minus 2 equals to 1.5 minus 2. I do it on both sides of the equation. Okay, so this is going to give me x squared minus 2x plus 1. 3 minus 2 is 1 equals to 1.5 minus 2. That gives me negative 0.5. Negative 0.5. So this now becomes exactly the same as the equation of y. Y equals to x squared minus 2x plus 1, which is this. So I just replace it with y. Y equals to negative 0.5. Then I just go on the graph, draw the line where there is z. Y equals to negative 0.5, which is somewhere here. Which is, okay, let me just twist the camera again so that you see. I just go here where there is z, negative 0.5. Negative 0.5 is here. Draw, I solve, I get the values of x. As simple as that. Okay, another example. Oh no, sir, you just, what if there was, if the change was on the value that is, if the change was on maybe where there's 2x, okay? So we're going to say x squared minus 2x plus 1. What if the change was here, and here there was 4x, okay? 4x, then there is plus 1 equals to 1.5. Still the same. I'm going to make it to be the same as this one. The easiest method. Simple as that. So what am I supposed to do? Well, for me to make it minus 2x, like the way that one was, meaning I have to add plus 2x. Since this one is minus 4x, minus 4x plus 2x is going to give me minus 2x. You see that? Okay, so what I'm going to do is 2x squared minus 4x, okay? Minus 4x, I'm going to add plus 2x so that it gives me minus 2x, then plus 1. I do it on the other side of the equation. 1.5 plus 2x, okay? So this is going to be x squared minus 4x minus, this becomes 2x, I mean. Minus 4x plus 2x is minus 2x. Plus 1 is equals to 2x, I can just hold it like this, 2x plus 1.5. Okay? So this one becomes exactly as the equation that connects all the points on the parabola. So this will become y equals to 2x plus 1.5. Solving this is the equation of the straight line. Solving that, it's easy. Okay? Solving this, it's easy. Equation of the straight line. Y equals 2x plus, so you just assume, you just pick a number like when x is equal to maybe 1. What is my y? All you have to do is come up with 2 points and plot there, you solve that. How can you solve that? So I do my values, okay, x1, okay, x and y. When x is equal to 1, what is my y? When x is equal to 1, what is my y? So here there will be 1, so the equation will be 1 equals to, where there is x, I put 1 plus 1.5, okay, this gives me 2 plus, okay, 2 times 1 is 2, so 2 plus 1.5, which is 3.5, okay, which is 3.5, so the value of y here will be 3.5, okay, then when x is equal to, I just try again, when x is equal to 2, what will be the value of my y? So here it will be what? My y will be, if I put 2 there in the equation, okay, let me just put it like this. If I put 2 here plus 1.5, what is it going to give me? 2 times 2, 4, plus 1.5, so this becomes 5.5. So 5.5. So I just plot these points. The first points being 1, 3.5. The second point is 2, 5.5. So these 2 points, once I put them there, then join them with a straight line. Where they cut the parabola, I mean, it's going to be the solution. You look at the values of x where they cut the parabola. Just finish it up. Maybe you are still confused. You say, but you're leaving things hanging, sir. Why don't you just finish up? So my point is 1.35, okay? 1,3.5, okay? In the x, 1,3.5, in the y, 3.5 is here, on the middle here. Okay, that's our first point. The second point is 2,5.5. 2,5.5. 2,5.5, which is here. Okay? Then I connect these 2 points. If you have a ruler, now I don't have one. I connect these 2 like that. Okay, so the solution is where it cuts the parabola. You find that it cuts the parabola here. Okay? Okay, I just connected it, I just made it longer. I made my parabola long enough so that I can get the other value as well. Okay, so it cuts here on negative 0.3 and the other one on okay, the other one is actually beyond because the graph ends here. So we just pick the one which is given, which is negative 0.3. Okay. The other one, it does not cut there. Thank you very much. If you've got any question, feel free to inbox me. The topic that you face challenges on, inbox me so that I can come through and share. Then also, if you can't see properly, get back to me so that I get to know I improve the videos to try and help you. Thank you.